do an example of the partial left test on some data. So here the data, what we have is the it's a made-up data of housing prices. So you could see here's the variety of housing prices, number, here's the list price and bedrooms, baths, all sorts of things. I took 10 predictors as estimating the list price, and I took 5 predictors for the reduced model, and just doing a quick, just guessing, bedroom square footage, year built, acreage, and whether it has a pool or not seem to be the best indicators of what the house price would be, or the mean house price would be. So the null hypothesis that I can get rid of the number of full bath stories, number of fireplaces, whether it has a fenced yard or not, or screen porch, can be eliminated from a model that contains the other parts. And then at least one of these predictors add utility to the reduced model. So actually I don't know what the answer is going to be, so we'll play along with this together. Here I did the regression and copied the full analysis variant. That would be, you can see all of those predictors and then the reduced. And so I found the sum of square error for the reduced, and this is it right here, 4.79. Remember, this e to the 12th just means times 10 to the 12th. And subtract that from 4.8. Just remember that the sum of squared error for the reduced will be larger than the sum of squared errors for full, because there's fewer predictors. And then divided by the number of predictors we eliminated, which was 5. And when I calculate this, would be 3.241. Now before I go to Minitab, let me just remind myself that my numerator will be 5 for the degrees of freedom, and the denominator new degrees of freedom will be, for the full, 234. Okay, so 5 and 234. So let's go see if I can go ahead and calculate this. Go to my graph, probability distribution plot, view the probability, and I want to do an F distribution, and the degrees numerator was 5, and as I recall, that's 234. And then I want to make sure I find the shaded area, and I need to put in my x value of 3.24. I always go to the right with the F test, so I'll put the right tail of 3.24, and it turns out to be that my p-value is 0.00753. So with my p-value, I guess I should probably then enter this in a bit. Since my p-value is equal to 0.007, let me just double check that to make sure that's what I got, 0.0076 or so, we reject the null hypothesis. We have evidence to believe that at least one of the predictors has utility in our model. So I better go back and figure out which one that might be. So anyway, so this is an example of the partial left test in action. Kind of surprised me actually as well.